Hello dear viewers, welcome to my channel Science and Technology. In today's show, Rocket Monday, we're going to talk about future flying on Mars. So let's dive deep into it. Now, first thing you have to understand, what exactly is the problem that we have to freaking fly on Mars? Well, by 2025, we have give or take 20 missions. Now, some missions landed, but had some injuries. So, give or take, we had 20 missions on Martian surface. As of now, as in like end of 2025, we have 3 active rovers, as in like things that are moving on their own power. So, at that point in time, we have Chinese Zhurhong, and then you have Curiosity, and then you have Perseverance. Now, at this point in time, you might think, that's GG. We have a lot of material, lot of technology. We would be scanning a lot of area. Here's the problem. These things are real. They are here. They are working. They are slow. And I mean slow. Now, again, you do not expect this puppy to be fast because this is a freaking toy. This, a little bit of speed you will expect, but that's a freaking nuclear powered 1-ton craft. And yeah, it's nuclear powered, but not nuclear reactor powered, nuclear radioactive decay powered, as in RTG powered. So, here's the funny thing, they still have the speed of 0.2 kilometer per hour. Basically negligible, like negligible. And to give you a context, like how slow we are talking about, Opportunity is the longest, as in like, it's the marathon runner that actually landed and moved. Here's the deal, how much it moved? Well, it moved 45 kilometer. I'm like, damn. But here's the deal, how long did it took to do 45 kilometer? Yeah, it took 15 years. Yeah, it is just pointless. Let's be real. It is pointless. If it's been crunching from year 2004 and by 2018 it just reached, it's like, bruh, I'm tired. And it have only clocked 45. And be mindful, Chinese also have the same issue. Rovers have the same issue, even though they have nuclear power, does not have to worry about solar, the same thing. Now, like, okay, why? Well, reality is Mars is a bit too far. On Moon, in principle, you can run a rover directly. You can do remote command. But on Mars, the radio delay is too goddamn much, meaning it has to be autonomous. Even the earliest one was autonomous, and that creates a penalty, as in like it has to be cautious. It has to know that going to this place I can go and I can pull back, because there is no control Z. Let's just put it that way. There is no control Z. You get stuck, you fall over, you roll over, the end. So they have to be very, very methodic, and there go 0.2 kilometer per hour, almost useless. While it was cool and all, but we kind of realized if we really need to do human Mars colony, yeah, these speeds are not good enough to do any sort of thing, so to say. So for planetary exploration is like, eesh. Now, Ingenuity happened. Now, Ingenuity was the first aircraft that fly on another planet. We are trying to send another thing that flies on another moon, but this would be the first one on a planet. And it was a demonstration mission. That's the ironic part about it. Meaning, NASA built this puppy, but it was designed to be like, hey, test it out. Can this puppy fly? Yes or no, the end. That was the only mission objective for this one. Not to like actually work. It was just, and again, that's how you're supposed to do. If you have a technology readiness level of lower status, as in like a 6 rather than 9, you'd be like, hey, we have the main mission. Let's test this side payload. And again, that's how we build a technology. We have the main bulk technology that is sorted, ready, good to go. And then we slap on something extra. If it fails, it's an auxiliary system, not a a mission threatening issue. And everything is fine and dandy. It has been done. This is a normal way of doing it. So this was that. However, this puppy outperformed even the optimistic expectations, so to say. Like, it almost was like, why you guys were scared, man? Like, why? Like, there were so many things that people were like, what about the dust will grind everything away? What will have the statics will build up and fry the solar panels, and this will that. There were so many horror stories or imagination that, this could happen, that could happen. It's like, and it was just like, bro, don't care. Like, it was solar powered, dual rotor. Now you might like, okay, why does it have to have dual rotor? Well, action equals reaction. If you are rotating the rotor clockwise, the body will rotate counterclockwise. To maintain that, you have to have a second rotor, and that gives you control. Basically, you can change the pitch or the RPM. I think this design only changed the pitch because again, RPM changing will require a bit complex of a gearbox. So dual rotor allows you to do everything in one disc, and it had some sensor and mild camera. And it was 1.8 kilogram on Earth. By the time it landed on Mars, it has weight loss therapy of 0.68 kilograms, 608 grams, not that heavy. However, it was big. Like, we are seeing it on a rover, but you have to understand this rover is almost size of a smart car, like, city smart car, very tiny car. This was 1.2 meter. Like there are people who are that tall. It was huge. The diameter was huge, and it was designed for 5 meter of altitude. Yes, it could fly higher than that, but 5 meter was expected to be like, if it goes 5 meter, motor ka puts it, it can crash land and be safe. Like, I'm good. So that's why that 5 meter. Again, you can keep flying as high as you can go, but either you will run out of power or your motor will simply give up. So 5 meter was like, what you call envelope, safe envelope, and they pushed through it also. That's why I said like it was overperforming on like, bro, why were you scared? And a flight range in one hop, because again it is solar power, the battery is the limiting factor, it should have been able to go to 300 meter. And when they tested it, like how much energy it was consuming while cruising, this puppy was consuming 350 watt. Not that bad. Not that bad. Like there are a lot of drone operators who are like, wait a minute, you are flying on Mars at only 350 watts. Yeah, and rotors are huge. That's why I said like it's huge, 1.2 meter huge. And this puppy did 72 flights. Let that sink in. Not one, not 10, 72. And 128 minutes of air time. It was successful. And it achieved 17 kilometers of distance. And that speed, it was maximum speed that it attained on Mars, not like on simulation, on Mars, 10 meter per second. Like it was fast, boy. And all the crash that happened, that was a oops from the algorithm. There was nothing like, it was just like it flew through to a place where it could not identify it. And again, this was the early demonstration. If they were doing it properly, they might have had some sort of like, base station that is screaming, hey bro, you are going this much from here. So even if you are seeing flat area where you cannot calculate like what the hell I'm doing or where am I going, you would have some radio fallback. They did not have that on this. But again, 72 flight for a demonstration mission on another planet. Shut up, take money. So this was surprisingly successful. So it was so successful, it opened what we classify as new avenue, meaning Ingenuity was solar powered. It was not plutonium, the tiny amount of plutonium that America still has remaining. There was not fighting over it. It's just like, bro, solar, bro, who cares? So that was mind boggling. And it was reliable. And very often it's like, that's why I said like everybody was scared of every variable. It's like, hey, what if dust clings onto it? And again, there are a lot of new researches like, what if they have this electrostatic deflector shield kind of system where the dust does not settle on it. All of that is like, bro, me good. Vibration, rotor, me good, me got this. So it was a very different kind of mindset now. So the mindset is, it's a great add-on for mobile land asset. As in, if you have any rover, a rover has motor that is powerful enough that it can move faster. But here's the deal, it does not know where it's going. Like its camera is very limited. But imagine you have a drone and it scans like in spiral pattern around it. So drone. Rover is drilling something cool, awesome, let it do what it's doing, and you scan the whole area around it, every single square meter. And again, it can do high resolution scan. At that point in time, you have a fully-fledged map from the origin point. Now you can move the rover very quickly. It's like, hey, I know till that meter, let's just say 7 meter ahead, I'm safe, I'm good, go 7 meter as fast as possible, plonk down, do your research, and then a rover will be, drone will keep scanning more areas, and then tada. So basically it will turbocharge what we call fast finding of area of interest. Basically, I think it is interesting, and then the rover will go and drill and do laser firing and all that, because you do have some sort of what you call power limitation. And you're like, okay, that's only scouting, but can this do anything on its own? Yes. You have a whole category of mission instruments that are classified as remote sensing instrument. Can you have a drill on it? In principle, yes. Realistically, no. You need much thicker atmosphere. There is a drone mission that's supposed to have a drill and supposed to drill and fly, but that's not for Mars. So on Mars, you will be limited to remote sensing instrument. Okay, what can you do? Well, you can have camera, LiDAR, really high resolution, ground penetrating radar. I used to think these things used to be like, consume a lot of power. Turns out like there are watts, like 3 watt ground penetrating radar. I'm like, what the hell? When did that happen? Yeah, that's the thing. NASA has a system. It's like, yeah, 3 watt. So they can do it. And hyperspectral imager. This puppy can scan the whole surface and be like, this is the chemical composition. And you have thermal camera also. So here's the deal. What is the benefit of having this sort of instrument? Again, it's unlikely in the current iteration where you're going to have all this instrument on one puppy. But the idea would be you will have multiple drones, and each of them will have one instrument and one overlapping instrument. So let's say navigation camera would be the overlapping instrument. That would be black and white high resolution camera. And then you'll have color camera, hyperspectral camera, LiDAR and all that. And once you overlay that many information, you say this rock is made out of this sort of calcification, it is made out of that calcification. The ambiguity will go down to zero, meaning zero, unless some new periodic element, periodic element is there. Vibranium is there, then it's a different thing. So that's a very, what you call, absolute data. You can see like we landed here and this went so far, like from a rover's point of view, this is like, shwee, and imagine you have 5 6 of them, and imagine each of them have its own unique instrument, and you are scanning every area like a spiral pattern. Like you have there spiral one, the another is behind it, another is behind it. You scan so much data, the volume of cube that you're going to create, data volume as we call it, it would be amazing. Like you will know what you're looking at. So that's the amazing aspect of it. Although, let that be very clear, can we do it today? No, not because we can't do it, simply because we can't transmit it. The bandwidth would be a limiting factor. You can send, again, you saw that this puppy was like only 1.6 kilogram on Earth. The rover is 1 ton. So we can send a lot of them like that. We good, bro. We got this. It's just that we do not have enough bandwidth, enough what you call throughput, that we can actually do thorough communication. It will be like, okay, transmit it to base station will transmit to orbiting asset, then wait for transfer. It will like, bro, the solar panel will reduce the solar panel size simply not because we can't put bigger one, can't do bigger mission, it's just that data is limited. So, and again, let that be clear. Look into deep space mission, many of them have data limitation. It's just like, hey, why don't we do more? It's like, yeah, we can do more. We can run this camera 24/7. It's just that we can't transmit the data. So everything was scaled down to that. What is the bandwidth limitation? Make sure everything just fits that little bit of buffer and the end. So Skyfall, this project that has been going around the internet, it's from AeroVironment in partnership with NASA JPL, Jet Propulsion Lab. So the idea is they're gonna deploy the shell. But again, this is a standard part, meaning they can just pick up a phone and there is a company, yeah, bro, we got you. And there are many rockets now. So that is a sorted part. And again, there is a very good chance this can be done much more cheaply if basically New Glenn starts to work. New Glenn is a bit better at high delta V missions, like liquid hydrogen based system. So it may be able to reduce the price even cheaper than basically Falcon Heavy, because again, Falcon Heavy does not have the upgraded second stage. So there is a scenario where you can have this sort of launches regularly, like who cares? So that is there. Mid-air deployment of 6 Ingenuity type craft. Now, why JPL is working on it is like they were the original team that worked on this sort of system. So there is some grounding on it. It's not just like CGI and all that. They have run the numbers, so to say, as they say. And you're like, okay, is it safe to have mid-air deployment? Be mindful, the 2 rovers that are nuclear powered and 1 ton, those have sky crane, as in rocket power crane that goes after the shell deployment, it goes, whoosh, it hovers while on rocket power, drops the cable, and then rover lands it. Once the wheels we good, the rover cuts the basically rope and then it flies away and goes boom. We have been doing it 2 times. So this is like, bro, this is easy. This is easy peasy. So this is much more what you call logical. Assuming you can figure out how the heck you're going to keep the batteries charged. Because again, this launch pad battery has to be like, yo, go. Battery has to be like, go mission. So it can be done. It's not that difficult, and it will allow much larger area scannage much faster. So even if you have 6 and one has thermal, one has a hyperspectral, one has ground penetrating radar, one has this and that. Again, that's the whole point of it. You're not going to have one instrument cloned 6 times. You're going to have different class of instrument, and then you're going to have very, very high resolution scanning. Now, okay, if you are doing remote sensing, can't you do with orbit? Well, here's the deal. If you have orbital class asset, you'd be lucky to get 1 pixel per meter. And again, in principle, we can do better than that. It's just that sending it to Mars is difficult. Let's just say, best scenario, money is no object, you're going YOLO on it. You'd be lucky to get 1 foot, like 1/3 of a meter per pixel. Why not smart? Here's the deal. There is something known as atmosphere and shimmering and distance. All of these elements combined, again, imagine you are firing a laser. Laser has to go through a thick ass atmosphere of carbon dioxide and dust. It will throw away the result. And if you are flying meters above it, like 2 meter or 3 meter, the resolution, the clarity, it would be on a completely different level. It's almost like, how Google Street View is, Google Satellite View versus Street View. It is not comparable, not even close. So it will be exponentially what you call high resolution compared to orbital asset. And each can be tailored for the payload. And in swarm matrix, basically each of them will not just like, okay, I'm going here, you go there. No, they will, if they keep scanning the same area, keep building up the data cube, they can do very serious analysis of soil. Even with like drilling would be only a little bit better than this, only a little bit, simply because it has so much data. If you know how the thermal is behaving, if you know the how hyperspectral is behaving, you know the how ground penetrating radar is behaving, you know enough, like, you good. And again, that's another amazing part. Let's assume they scanned it and one thing is not matching. Now you know that's the area of interest, go and drill there. So it's a really amazing thing, and no RTG needed. However, it might benefit from having a radioactive heater, not generator, but heater. Reason is because Mars does get cold at night, and they have to have insulator and heater, because again, if battery goes down too low in the temperature, kaputta. So having a radioactive, assuming it can be made light enough, as in like 1 watt heating element, without requiring any sort of electrical power. So if they save enough mass on insulation and heater and power on the heating element, it could make sense to add those, because that will, A, they are cheaper, B, it will allow them to have a bit more breathing room for their power electronics. So, and again, it will also increase their lifespan, because again, it will not freeze. So if, let's say, dust storm happens and the solar is like completely out, they can wait out the storm. They're like, bro, let it be 1 month. I can be, slowly, the temperature will not go down. Most of the things can, jump back in. So it can be added, and it has 6x mission redundancy, meaning as long as deployment happens, as long as each of them fly, you have redundancy. It's not like rover. If something bad happens to the rover, the end. Here it's like you have a lot of redundancy. So I think they say they are scanning, because again, from orbit everything looks flat. Once you actually send the rover, it's like, bro, this is a hellscape. So this solves that issue, and you can say it's not that big, not that expensive. So Skyfall, like, it has some essence. Like, it's not just like a pie in the sky, even though it's a pie, but it's good. So what can we expect in the future? Well, here's the deal. This is one of the concepts. Let that be very clear. Even though Jet Propulsion Lab is working, generally there are a lot of teams working on a lot of unique ideas. It's one of the concepts. Could it happen? Again, it depends on NASA's budget and how bold NASA is feeling. While that mission is logical, it does have, like, bold factor to be turbocharged. It's like ultra bold mission. So assuming next generation of rockets comes online, let's say Starship or New Glenn, and they're like, bro, we can do Mars mission for cheap, then I could see easily doing that. But if that does not happen in next 2 or 3 years, people are like, bro, put some rover there and let's coagulate, have 2 of them maybe, but like I cannot see the idea of like 6 flying objects only and without a landing base, because you might want to have landing base that may act as a radio beacon where you can, like, coordinate things, transmit data into this rather than directly transmitting. Oh, that's another issue. If you have to directly transmit to orbital stations, it will consume a lot more power. So having even a small rover, is just all it has is a radio beacon and transmitting back and forth, it may be more logical. So there are a lot of concepts that are in work. Another interesting one, I like the name Maggie. It's a noodles name in India. So this is a Maggie craft, and this is a VTOL. So the idea is, once they figure out that propellers can work, everybody's like, let's just make it bigger. This is a solar power one, and this puppy is gonna go high, as in 1 kilometer high, 1,000 meter up. Although the graphics and artist was lazy when they were making this, and it's like the VTOL, how the heck you gonna fold it? But again, it was one concept. So let that be very clear. Doing this will unlock Mars surface level exploration. Orbital scan got us only so far. Like, you need to do much more, what you call, actual scanning. We are not there yet. So this will be the next step. The only thing that would be better is like having super high power multiple rovers, where each rover can handle each other rover. If, oh, you got stuck, I can pull you out, or things of that nature. Then you can actually start to move them at high speed. Then yeah, but we are not there yet. So this is the next best thing, have a flying asset. So only backhaul would be limiting. Now, thankfully, NASA does know this, and they are working on laser payload systems, because if you have 10 watt of power, if you send a 10 watt of energy into radio beam versus 10 watt of energy in laser beam will carry more megabytes. So it is like, it's just law of physics. It's based on the wavelength, how much it, diverge. Radio beam sent from Mars literally becomes bigger than Earth. By the time you are sending it with a laser, it's barely size of a, continent. So not even continent, like they said, 1/8 of Earth's diameter. So it's much higher throughput, like same amount of power, but you can send much higher throughput. So that's being worked on. So the idea is you're going to have multiple hopping stations. So Martian asset, Martian orbital asset to Earth asset. That way you can have very high throughput, where you're like, okay, we have 5-6 drones and we are collecting enough data to be logical, so to say. So that is there, that asset has to be deployed, and it does have potential to be cheaper. Yeah, it will require laser assets, but again, that's a good thing to have. Once you have the laser infrastructure, super awesome, and other things can use. Like, this is another craft which is like, if you have dual rotor, why not just make a VTOL craft? And this will, because again, if you have 300 watts of power, this design, this wing design, can give you much higher speed at 300 watt, or lower wattage consumption, but high, much more stable flight. So that could be desirable. So there are a lot of options we have. So this is a very unique unboxing that has happened. People are like, whoa, think outside of the box. What if the box fly? So this was my presentation on basically Martian Skyfall. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst a friend. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.